Hello, I'm Mihir Agnihotri.
I'm Jackson Weber.
ECE.
I'm Duncan Dan.
And we will be discussing the circuit of a phone charger and its essential components. Phone chargers are very important items which seem like simple wires supplying power to our phones. Phone chargers are actually important electronic circuits which supply phones with the right amount of power without damaging the phone's battery. A normal phone charger will plug into a wall with 220 volts AC, and then the phone will receive 5 volts DC. There are three components in a phone charger which convert the AC voltage to DC. These components include a step-down transformer, a full-wave bridge rectifier, and a 5-volt voltage regulator. In this presentation, we will be focusing on the full-wave bridge rectifier. First, we will describe the process of rectification as well as what a full-wave bridge rectifier is.
Rectification is the process of removing the negative parts of the AC voltage to make a partial DC voltage. Since AC voltage is defined by a sinusoidal function, the voltage oscillates between a maximum and minimum voltage, which are equal and opposite values. This process of rectification can be done with 4 diodes arranged into a bridge. For the first half cycle of the AC voltage, diodes D2 and D3 are forward biased, while D1 and D4 are reverse biased. And in the second half cycle, diodes D1 and D4 are forward biased, while the others are reverse biased.
In the overall circuit, the current flows from the upper positive end of the transformer to the full wave rectifier. Current would flow into the diode D1 and lead into a load before returning to the rectifier and going through diode D3. This happens during the first half cycle. In the second half cycle, the current flows from the lower positive end of the transformer and into the full wave rectifier. The current will flow into the diode D2, then into the load, then back into the rectifier, going to diode D4.
After the current passes through the rectifier, the process of converting AC to DC is not over since there is still a ripple in the voltage. The process of filtration decreases the oscillation of the voltage by storing and releasing voltage while there would be less voltage supplied by the source. Since rectification cancels out the negative part of the AC voltage, there are gaps of the voltage for certain periods of time. The capacitor fills in these gaps and regulates the voltage and supplies the voltage regulator with a steady flow of current, and this allows the phone charger to supply the phone with the correct amount of power. The process of filtration allows a conversion of AC to DC voltage.
After the process of filtration, the voltage regulator creates a smooth flow of current, and the AC voltage is finally DC voltage. The voltage regulator is the final step in the phone charger's process, and the regulation of voltage in this circuit is what makes it so complex. While a phone charger seems like a simple device, it is actually a complex system of electronics which keeps our phones powered and safe.